All right, hello. This is a video lesson for Unit 2, Lesson 1, which is Intro to Functions. So functions is a really important mathematical concept in algebra especially. It's a relationship that we're going to talk about here. This will be a pretty quick video, as really this first lesson is just about whether or not things are functions and understanding what are and are not functions. So our target is I can identify a function. I can go and see a function and realize that it is one. So what is a relation? This is a definition we need before we can talk about a function. A relation is a mathematical relationship between a set of inputs, which we call the domain, and we'll talk about that later in the unit, and a set of outputs, which we call the range. Inputs is often our x variable, and outputs usually go with our y variable. So I like to think of functions as a machine, thinking of something going into the machine and then something coming out of the machine. A function is a type of relation for which every input has exactly one corresponding output. And what this really means is I know what I'm going to get back. If I put an A into my machine, I should get back a, let's say, a B. If I get anything back besides a B, it's not really a consistent machine anymore. You know, if I put in an A, I need to expect to get the same thing back every time. Now, if every single time I put in an A, I get back a C, that's reliable. That's a function, because we're getting back what we expect to get back. But if sometimes I get a C, and sometimes I get a B, and sometimes I get a D, it's not a reliable machine anymore. That would be an input having several outputs, when the rule about when something is a function is that it has exactly one output. So we're going to take a look at some of these examples. What I will tell you is this is very much a pause and rewind kind of video. So we're going to have you pause it. Try to see, is this a function, yes or no? If you're not sure, then just keep watching. But if you think you know, pause the video, take your guess, and then fast forward a little bit and see why I said yes or no. So is this a function? What I see right now that tells me this is not a function is this double 1 right here. So what this means is when 0 goes in, 3 goes out. When 3 goes in, 2 goes out. But when 1 goes in, sometimes a 1 comes out and sometimes a 3 goes out. That's not reliable. I don't know what I'm going to get back when I put a 1 into the function machine. So this is no, not a function. 1, the input, goes to multiple outputs. This is more just my justification over here. The biggest thing is that you're able to say yes or no, and for this one, it's no. Now for this one, I can actually tell, and again, I would pause this and try to guess on your own, but this one I can actually tell that this is a function right away, because none of the inputs repeat. So according to this list, if I put in a 0, I get back a 3. If I put in a 1, I get back a 4. If I put in a 2, I get back a 5. If I put in a 3, I get back a 6. I know what I'm going to get back for any of the 4 inputs. And don't worry about things like -1 or 4 or 5 as inputs, because we're only paying attention right now to what inputs are provided to us. And every one of the inputs given to us in this problem have a unique output. They don't go to 2 different places at once. So yes, this is a function. Now this one's kind of a trick question. 0 goes to 3, and we never hear about 0 again, so it's safe to assume that 0 always goes to 3. 3 goes to 2, and we never hear about 3 again, so it's safe to assume that 3 always goes to 2. Now you might say, well, there's 2 1s, so like you said earlier in this problem, that means it's not a function. But both of those 1s go to the same place. They go to 1. So if you say 1 as an input, I know I'm going to get 1 back as an output. So this is actually a reliable function. I know what I'm getting back. So I would say, yes, this is a function. Every input goes to exactly 1 output. Now, this is a different way of writing a function. This is called a mapping. So you see the inputs over here on the left and the outputs over here on the right. This is actually 2 problems at once here. Okay, so we're going to do each of these 2 problems. So for the problem on the left, the New York, what I see is that when 1 goes in, 23 comes out. When 2 goes in, 21 goes out. When 6 goes in, 74 goes out. When 3 goes in, 21 comes out. When 5 goes in, 64 comes out. When 4 goes in, 51 comes out. Now, some of you might be worried about 21 because 2 different things are going to it. But 1 output can go to multiple inputs. That's fine. Okay? You could have month 1, 2, 3, 4, and 5 all going to 60 degrees. That'd be fine. But month 1 can't have 2 different average temperatures. So this is actually a reliable function, this one on the left. This is a yes, this is a function. Because every month has its own unique average temperature, and that's good. Now, in the Pittsburgh problem, we actually have an issue. The issue here is that month 3 has 2 different average temperatures, and that doesn't really make any sense. Was the average 34 or was the average 41? You can't have 2 different average temperatures for the same month. So this really doesn't make any sense, and it's an example of 1 input, 3, going to 2 different outputs. So this is no. The input 3 goes to 2 different outputs. So this is not a function. So it's kind of nice to be able to see an input, see a function and not a function next to each other to kind of identify the difference. It's okay for multiple inputs to go to the same output. It's not okay for 1 input to go to multiple outputs. So now we've got 4 problems basically in one here, and we're going to see how many of these are functions. So for A, I would say yes, this is a function. And again, you can pause the video and try these on your own. I always recommend that. But this one is a function because every input goes to 1 output. 1 goes to 2, 2 goes to 4, 3 goes to 6, etc. For B, the guy that makes this not a function is 2. This 1 input is currently going to 2 outputs. You see the little fork here that's going 2 different places. So this is no, not a function. 1 input cannot go to 2 different outputs. In C, I have the same exact problem. 6. 6 is going to 2 different outputs, 6.3 and 2.5. That makes this not a function. For D, you might think it's not because it looks kind of funny and there's a whole bunch of arrows pointing to 100, but every input you know its output. 10's output's 100, 20's output's 100, 30's output's 100. I know the answer. If I ask you what's the output and you can answer it without having to think between a couple of numbers, then it is a function. So yes, this is a function. So the question really asked which ones are functions. So A and D are the functions. Now we get into a little bit of a bigger problem where they're making us they're making us think rather than just giving us the inputs and the outputs. So this one, the rule is movie title goes in and the director of that movie goes out. Okay? Now we're assuming, and I guess we could say directors, we're assuming that there is a lead director for any movie. So even if there are multiple directors, that there is one lead director that we can identify. So in this case, this would be a function, yes. Because if I put the movie in, you give me a specific title, and maybe we could consider remakes of movies with the same title, but we can differentiate those by the year. If I put in a movie title, I should get back out a unique director. I shouldn't have to guess. Okay? Now, for the second one, movie title goes in and cast comes out, the cast members. That one I would say is not a function because there could be many different cast members, not necessarily, it's not really saying, lead cast member. It's just saying cast members. And we would assume that there's lots. So I could say a specific movie, and I could name many different actors in it. So that is not a function. So now we have several more just little examples where we're kind of doing the same thing. Now remember, X means input and Y means output. So if a teacher enters an ID number into PowerSchool, they get a birthday out. Well, that makes sense. Any kid's ID number goes in, every kid has their own birthday. So it makes sense that we would be able to get one birthday for each ID number that we type in. So I would say yes, this is a function. For B, if the teacher types in a birthday, then they get an ID number out. This is a no, because many different ID numbers could pop out for a single birthday. There's more than one kid in the school with any particular birthday. So I would say no, it's not reliable here. For C, you plug a number into an equation. The equation doubles the number and adds 4 to it, creating an output. That is definitely a function. That's your first real example of a mathematical function. If I take 6 and I plug it in, double it, I'm going to get 12, add 4, I'm going to get 16. I'm always going to be able to do that, and I'm always going to get one answer exactly. So every input's going to have exactly one output. For D, you're planning a field trip or a trip, and on your computer you enter an amount of money you can spend on airfare. The computer gives you all the different possible places that you could fly to using that amount of money. Well, that's a lot of different options. It's a lot of X's. I could fly to I could fly to California, or I could fly to New York, or I could fly to Florida. Those are a whole bunch of different outputs for one input. So this is a no. You visit a website where you enter a zip code and it tells you the current temperature. Well, there should only really be one average temperature for a zip code. So this I would say is a yes. If I type in my city, I should be able to get back a temperature that my city currently is. You enter a number into a computer program and it tells you all the numbers that are divisible by that number. Well, if I enter 2, any even could come back. So 4 is divisible by 2, 8 is divisible by 2, 24 is divisible by 2. There's lots of different answers to things divisible by a particular number. So this is no, not a function. There's not just one output for that one X. If your counselor puts a GPA into school, they get back all the kids that have that GPA, the ID numbers of all those kids. Well, again, there's not just one kid in this school that has a 5.0. So if you put one number in, you might get several kids out. That is not a function. If you enter a social security number into a database, you get that person's name. Well, that is a function because every person has exactly one social security number, and a social security number only goes to a single person. So if you type in a social security number and are somehow able to get the person's name who has that, that's a function because there's only going to be one person that has that number. So you can see that this got a little bit trickier as we moved into more of the wordy problems. But the big idea here, the summary of this whole lesson, is what we talk about here. A function is a type of relation for which every input has exactly one corresponding output. So you just have to ask yourself, could that one in go to multiple outs? Then it's not a function. Does it go to exactly one output? Then yes, it is a function. And that's it for this lesson.